All right, we're in Algebra 2. We are on Lesson 3-6. Today is November 8th, 11/8. So dividing by polynomials. So 3-4 was dividing by monomials. 3-5 was dividing by binomials. Today is dividing by polynomials. So it's a review kind of 3-5 with an added little trick. Here is a trick question. Here you go. Can we not play with the markers so much? I know that they're super fun. 143. How many times does 143 go into 87? 0 times. You already know the trick question. And then the remainder would be? What's the remainder? 87 over? Over 143. There it is. Same thing happens in terms of a polynomial, but to know whether or not it's a 0 here, you have to check the degree. So my question now is 2x to the power of 3 minus 3x to the power of 2 plus 8 goes into 6x squared plus 4x minus 7 how many times? Once. So if I go one time, then I'm going to multiply everything by 1, and I'll eventually be writing a 2x to the power of 3 here. You'll notice that there is no 2x to the power of 3. That used to be, it would be right here to the left of 6x to the power of 2, because everything is in standard form. So because we can't do that, we have to write 0 again. And then the remainder is just going to be this thing in the denominator, this thing in the numerator. So let's go ahead and squeeze that in here really tightly. So it's going to be 0 plus 6x squared plus 4x minus 7. All of that is going to be divided by 2x to the power of 3 minus 3x squared plus 8. So with that, that is the one trick, but let's get some review in here. Example 1. I want to divide x to the power of 6 plus 5 divided by x to the power of 3 plus x to the power of 2. How am I going to do this? I can't use synthetic division. Someone quietly raise their hand and tell me why. Why can I not use synthetic division? Fiona. Because what has the power? X. Which x? There's 3 of them. So the x to the 6, that's not quite right, but you got the XP already for the attempt. Gio, you want to take a guess at it?
Yeah, we can't do it because there's an exponent.
Exponent where?
When there's an exponent, like, you can't do it.
So you can actually do it when there's an exponent. For example, if I see this problem on the left or on the right hand side, if I have x to the power of 3 plus 2x squared plus x, that can be divided. So there are exponents. I can divide that by x minus 1, and this is still, I can do this with synthetic division. Fiona, you want to take another? Oh wait, hold on. Stego, go for it.
You can't do it because
there's exponents on the right hand side. There's exponents on, yeah, what you're dividing by. So this exponent right here and this exponent right here, both of them mean that you can't use synthetic division. I can only have something of the form x plus or minus a number. So we can't use synthetic division. We know that now. So we have to do this the long way. Let's go ahead and write this down. Again, skip a line right here. Don't write anything on that first line. Skip that line. We are going to be writing x to the power of 3 plus x to the power of 2. Bless you.
Thank
you. You guys are definitely being positive. You're working towards it. I'm going to write x to the power of 6 here, but the next term should be a degree 5 term, but I have no degree 5 term to put here, so what should I do? I can put a 0, yeah, plus 0x to the power of 5, plus 0x to the power of 4, plus 0x to the power of 3, plus 0x squared, plus 0x plus 5. Tons of placeholders. Okay, here we go. We have all of our placeholders ready to go. How many times does x to the power of 3 plus x to the power of 2 go into this binomial? It is like there's a ton of terms there, but it's really a binomial. Quiet raise hand out there, Gio?
2.
2? Not quite, because if I do 2, it's going to be 2x to the power of 3. I'm looking to somehow get rid of this x to the power of 6 term. James?
No, I wasn't.
Oh. Just Fiona again? Is Fiona going to be the sole participator? This is why we need the participation cards. She uses 2, and then she has to wait until everyone else gets rid of their cards.
Oh, really?
Eva, go for it.
Is it x squared?
X squared. What do you guys think? Thumbs in the middle.
Yeah.
So let's go ahead and put x squared. I write it above the degree 2 term, x squared, x squared. And when I multiply x squared times x to the power of 3 times x.
Wait, I found my mistake.
You found your mistake? What's your mistake?
X cubed.
It's x cubed. Okay, so now that we're multiplying x cubed by x cubed plus x squared, I'm going to get, Eva, can you do this for me?
X to the 6.
X to the 6
Plus x to the 5th.
plus x to the 5th. There it is. Thank you, Eva. So you get the points for catching your own error too. Boom, attempt, and error. Tons of XP. Nice. All right, and what do I do next? Someone new. Someone new. Fiona's already done this before. Someone new. Andrea, you subtract them. And when I subtract them, what do I get? 0 there and
0? No, wait. Negative x to the 5th.
negative x to the 5th. There it is. Thank you, Andrea. Boom. All right. Next, I have to figure out how many times this goes into this. How many times does x to the power of 3 go into negative x to the power of 5? Quiet raise hand. Quiet raise hand. I need to hear from someone roughly new or hasn't participated twice. I guess I could call Andrea, but I want to hear some from maybe James, Chris, or Stego. No? Okay, Andrea, go for it.
Squared.
X squared. So if I multiply x squared by this binomial, what do I get? You want to do it again, Andrea?
Oh, x. Wait, x squared. Yeah.
X to the 5th. And then we should have
X.
brought that one down. Yeah, plus 0x to the power of 4 plus x to the 4th. Okay. Okay, so Gio has seen something interesting. Can you say that louder, Gio? Say what you just said again. It's not
Negative.
Say it louder.
Oh, so it's not negative.
Okay. So can someone maybe expand on what Gio's trying to say?
It's x. I don't know.
There's an error up there is what I'm trying to say.
Okay.
Who can catch that error? You want to try it again, Gio?
Yeah. X to the 5th power has to be negative.
It has to be negative, so what would you change? In order for this to be negative, I can't just arbitrarily say, okay, I'm going to make that negative. So if I want to make that negative, what else in this problem has to change?
The first one has to be positive.
First one, which one are you talking about?
The one above. I don't know.
Are you talking about this one up here? This one down here?
Yeah, someone else can go.
All right, Fiona.
The x squared, like on the top, should be negative.
Yeah, so let's come back here. Let's erase this positive and turn it to a negative. Why does it do that? I guess I actually got rid of it.
When Andrea was answering.
I was thinking that you were going to say that, but then I was waiting for someone to catch the error and you put your hand back down. So that means that both of these terms are now negative, so let me come back here and make this a... Why does it do that? There it goes. And that's a negative. Okay. So we fixed that error, and now what do I do?
Subtract.
Subtract. So what is this going to turn into, Eva?
X to the 5th. The x to the 5th is allowed.
Okay. And you get
X.
x to the 4th. Nice. We are totally going to run out of room on this one, aren't we?
Yeah.
Hopefully we'll be seeing a pattern that emerges that makes it so that we don't run out of room. And we'll see if anyone can find that pattern. So next I'm going to bring down this 0x to the power of 3.
So you're basically
Power of 3. And now I'm asking how many times does, oh, we're not going to run out of room because we can't go very much farther. I see that. X to the power 4, what do I do next?
That's
Quiet raised hand. James?
Would it be positive x?
Positive x right here, which multiplies by this binomial to get
X power 4 plus x cubed. Yeah.
x cubed. Yeah, I agree. That's correct. Nice, James. And next step. What are we doing? The procedure over and over and over again. Andrea? Subtract. And then you get negative x cubed. And we are almost done. Let's go ahead and bring this 0x squared down, 0x squared. Oh, what am I doing here? Okay, I see my error up here. Do you guys see it? This is a teacher error. This is not a student error. Andrea has the first hand.
I don't know.
Andrea, go for it.
Shouldn't it be the x? Shouldn't the x squared be like 0x? I mean, yeah, 0x squared.
I should have shifted everything left. Yeah, that's what's messing me up. And I think it's because originally Eva told me x squared, but I should have caught that. Yeah, so thank you. Log it in your extra credit tracker, please. So let me drag.
Wait,
I should have had it like that.
well, I can't. And I got it right.
Okay. Next. I have to ask myself how many times this goes into this. I'm just going to give it to the first person so we can get through this. Fiona? 1. And that turns into what down here? All right, someone do the next step for me. First hand, we'll get through this really quick. Eva?
You subtract and then it's going to be x squared, and then you bring down 5, so it's x squared plus 5.
So it's going to be negative x squared underneath here. And then I have to bring down the,
5.
just the 5, not the
Or
0x.
x.
Okay. Plus the 0x. We brought down the 0x. And next step, what do we do, Fiona?
Wait, I think it's supposed to be a negative
Why should it be a negative 1? Oh, yeah, it should be a negative 1. Why?
because it's negative x.
Yeah, so we have to match it. So we have to match the negative. So this should have been a negative to begin with. That should have been, let me erase this. This should have been a negative to begin with. Why did the lines always get messed up? So that should have been negative, and then when we subtract it, then it turns into the positive. So it goes chunk, chunk, like that, which means this is now a positive x squared plus 0x. And finally, there's one last step. Can anyone see it? Fiona, go for it.
Do you have to bring down the 5 too?
You do have to bring down the 5. Tell me why.
Because x to the third plus x squared doesn't go into x squared.
Yeah, we're done. This is degree 3, this is degree 2. We can't go any farther, and by writing it above the correct symbol, you can already tell we can't go any farther. It's a good indicator of saying, oh, now we do our remainder. So our remainder, I have to write this above because we ran out of room here. I should have conserved space over here on the left-hand side. I can say, yeah, that is going to be plus, and then Fiona, can you tell me the fraction up here to get that xp?
X squared plus x plus 5.
Plus, well, we have 0x, right? It was 0x, so we don't really have to write down the x.
X squared plus 5.
Yeah, so x squared plus 5 in the numerator, and the denominator has
X to the third plus x squared.
x to the 6 plus 5. Or sorry, x, I don't know what I'm saying here. X cubed plus x squared. There we go. So that's our final answer. Our final answer is right there. Whew, yeah, that was a long one.
And it's just gonna be a shorter one.
And there's no shortcut for this one, unfortunately.
Oh.
You just have to do it long. All right, let's try this one. This one will be a little bit shorter. And I think that's, do we need to do this one? Oh yeah, so we can probably finish this in like 10 minutes. Here we go. Let's set up this problem.
Sure.
X to the power of 3 plus 3, that's going to go into x to the power of 5 plus 2x to the power of 4. Can someone help me read the rest of this? What do I put inside?
You got it.
I got it. No, I'm going to mess up. I need help. Minus x cubed. Shout it out.
Plus 0x squared
There it is. Plus 0x squared. You didn't fall for the trap.
plus 0x
Plus 2. There it is. All right. I'm going to do this in individual groups. Go through this and see how fast, well, not necessarily how fast, how accurate you can get it. All right. Example 2. It's harder than we thought. Here we go. So how many times does x to the power of 3 go into this thing?
X squared.
X squared. Yep. 1x squared. So when I do x squared, I'm going to get a x to the power of 5 plus 3x squared.
Oh.
That's so confusing.
That makes much more sense.
Yeah, you got to put it in the correct place, unfortunately.
Unfortunately.
So when I do that, then I get a minus and a minus here, and I subtract them. So that goes away. That's 0, and I'm left with a 2x to the power of 4, and I'll have to, so it's up to you how to do this process. I'm going to just bring down the next term and then remember that I need to bring down this negative 3x term later. But right now, this 0x squared is now a negative 3x squared. So I'm going to bring down this negative x to the power of 3, and I'm going to just not, I really don't want to forget about this guy. He was important. Look down that whole row and just do it step by step. So that's my hint. See if you can try it on your own now. All right, Mr. Sindel has been not on task, and he apologizes. I apologize. So I'm going to go through this kind of fast. So I need to ask myself, how many times does x to the power of 3 go into 2x to the power of 4? And the answer is 2x. There it is. So 2x to the power of 4. 2x times 3 is 6x, so plus 6x. And I need to subtract them. So let's go ahead and subtract them with, I don't want to do red because red, green, minus, minus, chunk. Those go away. And then I'm going to get this negative 7x. Why do I? Oh. Yeah, who wants to get it? Eva?
Finally. Okay. You're gonna move the 6 to where the 6x to where it should be.
Right there, yeah.
Oh my god, dude.
Okay, I'm actually confident in the answer.
Whoops. I'll fix that later.
Wait.
Coming back here. So I have to write the 6x underneath here. Mr. Sindel made that mistake by going too fast. Plus 6x. Shunk. Yeah, extra credit. Log in your extra credit tracker. Let's change this to a negative and a negative. And then finally, when I do that, let's switch back to,
No cancel.
we'll do blue here. Cancel here, and I'm left with a negative x to the power of 3. And I'm going to bring down now this negative 3x squared minus 3x squared. And I'm going to ask myself, this goes into this how many times? Negative 1 times, negative 1 times. And negative 1 times that is going to be negative x to the power of 3. And negative 1 times a positive 3 is a negative 3. So I'm going to write that negative 3 right here. And my remainder here is going to be a little bit tricky. Shrink. So I'm going to add and add that, switch the sign so that goes away, and I'm left with, I'm going to rewrite everything that I have so far. I have this negative 3x squared. I have this plus, wait, it's a negative. It's a negative 6x. Negative 6x, and I have a 3 plus 2, which is plus 5. My remainder is this guy. So I'm going to say plus this, oh, I guess I should,
Wait,
yeah,
is that
plus,
an X? Yeah, right?
which one?
Never mind.
Plus this negative 3x squared minus 6x plus 5. All of that is going to be divided by x cubed plus 3. All right, and really quickly,
So let's do the
Wait, why is it 5?
this 5 right here, because I had this 2 originally, and then I added this 3 to it to get 5.
So that is the remainder, yeah?
That is the remainder. There it is.
Where did we need?
-3 on the bottom.
Oh.
Oh yeah, so I made that mistake also, Stego. You were not alone. Lots of errors were made. Lots of learning happened today. And really quickly on the back, how do I do this problem? You can do this in about 10 seconds.
No, you can't.
Yeah, you can, because it is a
Trick.
it's a trick question.
Oh yeah.
So your answer is 0 plus 2x to the power 3 minus 4x squared plus 1.
Oh.
Yeah.
I knew that. I just-
So our reasoning here, and if you can't see that, or if you think you might forget in a week, you say that this, the way that you find trick questions is this degree is higher than
So it has to be lower
than
Same.
this degree. Yeah, this one has to be lower. So if this degree is higher, then it is a trick question. And that concludes our notes.